So in this video, we're continuing the average rate of change, but now we're going to take a look at a rate of change from a situation and then a rate of change as an expression. So the nice thing about these situations is that since we're just in the math class, a lot of times they're going to give you the formula. So unless it's a formula that you're expected to know. So let's take a look at what's going on here. It says the electrostatic force F measured in newtons between two charged particles can be related to the distance between the particles d in centimeters by the formula F of d is equal to 2 divided by distance squared. Find the average rate of change of force if the distance between the particles is increased from 2 centimeters to 6 centimeters. So remember our average rate of change, we're going to calculate our delta y. And our delta y is going to be figured out by going f of 6, trying to find the y value that's generated from these x values, okay? So remember the input is distance. So the x values are going to be distance. So minus f of 2, and remember that's the ratio. So delta x is going to be 6 minus 2. All right, so let's go ahead off to the side, calculate f of 6. So when you plug in 6, you get 2 over 6 squared, which is 2 over 36, which is 1/18. And then we also need to calculate f of 2. F of 2 is 2 over 2 squared. Remember our function is here, 2 over d squared. So 2 over 4, which is going to give us 1/2. So we can see for sure that our denominator is going to be a 4, but now we've got to go 1/18 minus 1/2. And so here it's just going to be calculating your algebra. So I'm going to go 1/18 minus 9/18. So of course all I did was multiply this by 9 so that we get common denominators. And so now I've got negative 8 over 18 divided by 4. And so remember when we do that, we've got negative 8 over 18 times 1/4. And I like to reduce beforehand, so I get 1, I get 2. So I can also go 2 into 18 and do that. So let's go ahead and do that. That would be a 1, that would be a 9. So now we're left with negative 1/9. And then that is going to be our final average rate of change over that interval. All right, so let's take a look at a rate of change dealing with an expression. So it says find the average rate of change, and then here is our equation. But it's telling us that the interval is from 0 to a. So if we had numbers like we've had all up until now, when we plug in numbers, we're going to get numbers. But if we plug in letters, then we're going to get back letters. Okay, so it's no different. Let's just calculate the average rate of change, which says delta y. But remember, delta y is going to be, and I'm going to do g because the function is g of a, right, that's the second term, minus g of 0. That's going to give us delta y over delta x. And of course, delta x is just going to be a minus 0. Which, if we were to simplify any of that, we could look like a minus 0 is just going to be a. So we can simplify our denominator rather quickly. But let's go ahead and off to the side calculate g of a. So in this equation, if I were to replace t with a, I'm going to get a squared plus 3a plus 1. And then if I do g of 0, I'm going to get 0 squared plus 3 times 0 plus 1. And again, I'm plugging it into this equation here. So g of 0 is going to be 0 plus 1, which is just going to give me a 1. So if I were to take this information here and write it here, I've got a squared plus 3a plus 1. Remember, this is a minus, right? So we've got a minus. And then g of 0, and g of 0 was 1, so we have that. Now we just need to clean it up a little bit. So let's go ahead. I've got a squared plus 3a, the plus 1 minus 1 cancel, and it's all over a. I want to be able to reduce. Both terms have an a. So I've got a plus 3 all over a. And then you can see that these a's reduce, and now I'm just left with a plus 3. Okay, so that would be my average rate of change as an expression.